A really great thing we can do with arrays is build up a bunch of arrays that describe different qualities of a bunch of different objects. Say that the arrays describe their locations and their sizes and their colors, and we can take every combination of these things to create tons and tons of objects. This is really easy to program if all the arrays have the same length. But if some of the arrays are shorter and some are longer, then we can't just use the same index for all of them. A really clean way to handle this situation is to use Modulo, or mod. There's a whole video on mod, which I'll assume that you've seen already, so here I'm going to focus just on using Modulo for arrays. You may remember from that video that we write the modulo or mod operator with a %sign. When we compute a mod b for two integers a and b, we get back a value between 0 and b minus 1. In effect, we take the value a, and if that's larger than b, we take b out of it. And we keep doing that as long as a is larger than b. What we're left with at the end of that process is a number between 0 and b minus 1. It's what's left over from a when we removed b as many times as we could. Well, this is just perfect for indexing an array, because if an array has b entries, then 0 to b minus 1 describes its bounds. So you'll write this kind of thing all the time. Suppose I is an integer, and it starts at 0 and it just goes up and up and up. Maybe it's the frame count. v.length, of course, is the length of v. When I is 0, I mod v.length is 0. And then as I goes up and up and up, the result here goes 0, 1, 2, 3, 4, and so on, until it reaches v.length minus 1. When we get back v.length minus 1, then I goes up by one more, and the result of this expression goes back to 0. And then it marches its way up, 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 up to v.length minus 1, and then back to 0, repeating over and over. Let's actually see this in practice. Suppose we want to make a sky full of kites. So to get started, I'm going to create 3 floating point arrays. One to describe the altitude of the kite, another to tell me its compass heading, and another to tell me how long its tail is. Now notice that these have different lengths. Altitude has 7 elements, heading has 3, tail has 4. If I want to make 7 kites, I have to reuse the entries from heading and tail. So here's how we can do that. I'll write a for loop that goes from 0 to altitude.length. So I in this loop will take on the values 0 through 6. Well, we can certainly ask for altitude sub I and store that into a local variable. We can't ask for heading sub I because the 4th time through we'll get an error. Instead, we'll ask for heading sub I mod heading.length. So now as I goes through the loop, we're going to get back heading sub 0, heading sub 1, heading sub 2, heading sub 0, 1, 2, 0, 1, 2, repeating forever. Or at least as long as I keeps going up. Similarly, to get a value out of tail, I ask for tail sub I mod tail.length. And now I'll get back tail sub 0, tail sub 1, tail sub 2, tail sub 3, back to tail sub 0. So each array works its way through all of its elements and then starts over again. And then of course, I'll build a kite and display it. I use this technique frequently when I want to create a large number of objects by recycling a relatively small number of colors. I'll declare an array of colors, and then I'll fill it in with something. Here I just have 6 primary and secondary colors. Now I'll write a loop. Maybe I'm going to make 1,000 objects. I can always get a valid color by asking for I mod colors.length. That in this case, that will always give me back a number between 0 and 5, and it will just recycle these 6 colors over and over again. Let's actually use this technique in its most natural application, drawing rubber ducks. My rubber duck has 6 colors. First, there's the body color, here it's yellow. Then we have 2 colors for the beak, one for the upper beak, one for the lower beak. His eye has 3 colors. In this case, we have a white iris with a little blue pupil inside of it, and inside of that is a little white highlight on the pupil. To make a whole lot of rubber ducks, I'll create 6 color arrays, one for each body part, and then I'll march through the arrays, creating one duck for every combination of colors. Here's the program running, drawing just one rubber duck with all of its default colors. Now I'll create 6 different arrays of colors. Each array will have a random number of entries, and each entry will be a random color. Here are all of those arrays. So at the top, we can see that we have an array for body colors, and there are 7 colors. For the lower beak, I have 6 different colors. For the upper beak, I have 8. The iris has 3 different colors. There are 9 choices of colors for the pupil, and there are 3 choices of color for the pupil highlight. As you can see, I'm just marching through all of these, choosing one color from each list to create my duck. In the upper right, you can see the duck number. I'm just updating that once per second, so we get to see each duck for a second. If you look at the big black boxes that show you which color is currently being selected, you can see that for each array, the box works its way from the left all the way to the right, and when it hits the end, that one jumps back to the start, but the other arrays boxes keep going if they have more entries available to them. This is because I'm using Modulo. Every array is being indexed by the duck number modulo the length of that array. So for the top array of body, I'm getting the numbers 0 through 6, and then it goes back to 0. But lower beak only goes from 0 to 5 before it goes back to 0. And each array is using the duck number mod the length of that array. Taken together, these arrays would give us 504 differently colored ducks. We can see a whole lot of the ducks all at once if we make a grid. So here's a grid of a whole lot of ducks. And I can show more ducks or fewer ducks just by changing some controls from the keyboard. All of these ducks are different because, again, going back to the previous display, we have 504 of them before they begin to repeat. We can work with all of these different arrays using the very same index, duck number, but by taking duck number mod the length of that array, we always get back a valid entry from within that array of colors. In this program, at any time, I can generate new random arrays. So let's generate a new one. Oh, that doesn't have enough colors. Okay, so there's a new random set of colors, and you can see each array has a random length and gets filled with random colors. Let's see if we can make some big arrays. I'll just keep going until we get some big guys. All right, that looks pretty good. So now this combination of colors would give us 2,310 different ducks before they repeat. We can, of course, always go back and check in on our grid of ducks. And we can even march through the grid and look at all these different combinations. All of these ducks are unique. They all have a different set of 6 colors. In general, anytime you're working with an array where you think you just might be asking for an element of the array that is beyond the bounds of the array, include mod the length of the array after the index. Then you can be absolutely confident that you're always asking processing for an element of your array, and your programs will run beautifully.